So, a few months back I stumbled across this press article from Vodafone, where they have successfully tested their first network implementation of Uplink-Tx-Switching. They claim to have reached a peak uplink performance of 273 megabits per second using this feature, in combination with a Qualcomm-based 14th series Xiaomi smartphone. And this got me wondering, because in Vodafone Germany's network, 5G uplink carrier aggregation is not yet implemented, but now they have tested Uplink-Tx-Switching, which is sort of a combination of two uplink enhancements, Uplink MIMO and Uplink Carrier Aggregation. So what exactly is this feature about? To get a bit of an understanding about the technology behind it, network operators in countries like Germany use multiple 5G bands to carry data over the air. There are so-called low bands in the 700 MHz spectrum, mid bands in the 1800 MHz and 2100 MHz spectrum, and there are high bands in the 3.5 GHz range. One of the key differences between low and mid bands compared to high bands is the duplex transmission mode over the air. Low and mid bands use frequency division duplexing, which means they use different channels for downlink and uplink data transmission. Each channel is a continuous stream of data in one way, either transmitting or receiving data, which explains why FDD-based bands have paired spectrum blocks, one for downlink and one for uplink. High bands, like the N78 3.5 GHz band, uses time division duplexing, so that downlink and uplink data share the same spectrum and are transmitted or received time-shifted. Some common TDD downlink and uplink patterns operators use in Europe are DDD-SU times 2, where multiple consecutive slots are scheduled to carry downlink data, followed by a small guard period, which is then again followed by a slot carrying uplink data to the base station. Depending on the location and the distance of a handset that is connected to a 5G base station, the timing of these slots have to be as precise as possible to avoid overlaps of data streams. Usually, handsets are capable of aggregating multiple 5G bands together to increase the capacity and therefore the downlink performance. But due to the nature of mobile handsets and their limited power, because they run on batteries, the devices themselves are often limited to one or two transmit modules to conserve power. That means that handsets are capable of sending back data in one single band only using one antenna, or at best use two uplink data streams. There are two key techniques which increase the uplink data throughput from the handset to the base station: 5G uplink carrier aggregation and 5G uplink MIMO. 5G uplink carrier aggregation allows the handset to use up to two different 5G bands for uplink data transmission, while 5G uplink MIMO enables the handset to use spatial multiplexing via two data streams on the same 5G band. The 5G uplink MIMO feature is mostly used on 5G TDD bands, while 5G uplink carrier aggregation is typically used on both TDD and FDD bands. Now back to the Uplink-Tx-Switching feature. This feature is basically combining the best of both uplink enhancement features, 5G uplink carrier aggregation and 5G uplink MIMO. As soon as the base station advertises support for Uplink-Tx-Switching, the handset can use one TDD and one FDD 5G uplink band to transmit data to the base station. As long as the TDD band is in downlink slot's time domain, the handset uses one transmitting antenna to transmit data over the FDD band, but as soon as the uplink time domain of the TDD band is scheduled, the handset switches both of its transmit antennas to use Uplink MIMO for transmitting two data streams to the base station. Effectively, the handset can utilize 100% of the 2x2 Uplink MIMO slots in the TDD band and roughly around 75% of uplink in the FDD band, which almost triples the uplink throughput performance compared to devices which just use one single transmit antenna. The trick is to take advantage of the time division duplexing of the 3.5 GHz high band, while occupying the downlink time domain of the TDD band by sending data over the FDD band instead. Of course, the handset requires the necessary hardware-based components like antenna modules, filters, transceivers, etc. to take advantage of this feature. Not too long ago, first smartphones seem to have appeared that bring this feature to the mass market. On websites such as this one, users can upload their own UA capabilities message and let the website parse and display the supported carrier aggregation combinations of their handsets in a human-readable format. Using the advanced search feature of the site, it is possible to search for specific capabilities and band combinations, such as devices that support Uplink-Tx-Switching. According to the results on the site, the Xiaomi 14 Ultra seems to support this feature already. But depending on the carrier policy inside of the device, it might not be enabled by default and has to be enabled manually. Anyway, that's it for now. Thanks for watching and see you in the next video. Bye bye.